right, well, we got 44. Well, good afternoon, everybody. I just wanted to welcome everybody to the webinar today, produced by Oshkosh Corporation. Jason Shively, he's going to go over the Oshkosh Eco EFP overview system of their input foam testing system. We asked a couple things for good housekeeping. A wired connection is preferred over a wireless one. Feel free to ask questions in the chat box. If you guys have any questions, we'll answer those at the end. And just remember, you will get a replay 24 hours after this in your inbox, and you can keep that. So now we're going to turn it over to Jason.
Hi, my name is Jason Shively. I'm the Director of Engineering for Oshkosh Airport Products. We're here today to talk about the Oshkosh Eco EFP system, which is the input-based foam test system for the Oshkosh Striker. The Oshkosh Eco EFP system is an input-based foam system specifically designed for the Oshkosh Striker. It's completely integrated in the truck and allows you to do your foam testing without discharging foam on the ground with just the truck itself. There's no additional equipment that's needed to set up the test and to run the test. The Oshkosh Eco EFP system is both easy to use and versatile. The user interface allows the operator to go through a step-by-step process to do the foam test. All the data is recorded within the vehicle, and the operator does not need to hook up anything to the vehicle, do any setup time, do timing, or any calculations to figure out the foam percentage. The center of the Oshkosh Eco EFP system is the test screen that is located on the structural panel of the truck. This is where the operator selects what tests they would like to run. This user screen will lead the operator through the test screen by screen and allow them to run a test without putting foam on the ground. The Oshkosh Eco EFP system uses 2 flow meters on the truck to do all the calculations. As you're going through the test, the system is recording the foam flow out of the discharge along with the foam percentage. Both of these data points are stored on the vehicle. It can be used to both troubleshoot and verify the foam system functionality. The user interface will lead the operator through the test procedure screen by screen with easy-to-follow instructions. The system will allow the operator to pick what discharge tests are to be run. Multiple tests can be done back-to-back if desired. We will now demonstrate a foam percentage test using 2 discharges, low flow from the bumper turret and high flow from the roof turret. Once the start button is pushed, the system will prompt the operator to engage the foam system. Next, the system will request activation of the discharge to be tested as indicated at the top of the screen. Once the truck sees the discharges flowing, the system will begin the test procedure. The timer on the screen will start the countdown for the test. The first 30 seconds of the test is used to allow the system to stabilize, just as an output-based foam test would be run. When the timer gets to 10 seconds, the system will start recording data. The flow rate and foam percentage over this 10-second period will be averaged and used as a test result. At the end of the test, the system will ask the operator if they would like to save the data. Next, it will prompt the operator to disengage the discharge. If a second test is selected, the system will then ask for the second discharge to be activated. Once activated, the system will then start the second test. The discharge being tested is shown at the top of the screen, while the instantaneous flow and foam percentage are displayed on the screen as the test is run. Once again, during the last 10 seconds of the test, data will be recorded and averaged for the discharge flow rate and foam percentage. The operator will be again prompted to save the data at the end of the test. At the end, the system will instruct the operator to turn off the foam system before exiting the test screen. The history screen will then be shown, allowing the operator to see the test results and timestamp of the test just completed. The Oshkosh Eco EFP system stores all the data on the truck. There is a historic screen that you can go to look at the last active discharge test that was completed. That is simply done by pushing the lower button here. On the screen, it'll have a list of all the discharges, the discharge flow rate, the foam test percentage, and a date and a timestamp. From there, you can also go to an archive screen. In the archive screen in the top right here, this will allow you to witness or review each test that has ever been done on the truck. This is also downloadable on a USB drive simply by inserting a USB and hitting the download key. The Oshkosh Eco EFP system is customizable. In the settings screen, it allows you to change the flow rates from gallons per minute to liters per minute, and also allows you to set the date and time. Thanks today for spending some time to learn about the Oshkosh Eco EFP system, designed exclusively for the Oshkosh Striker. If you have any questions, comments, or would like to get a quote, please contact your Oshkosh representative. Thanks and have a great day.
Hi there, everybody. My name is, like Kevin said, is Jason Shively. I'm with Oshkosh Airport Products. Here today to talk to you about the Oshkosh Eco EFP system, and have a quick PowerPoint here to run through with you to give you a little bit more feeling on the system details and talk about some of the installation challenges and opportunities we've had with doing retrofits in the field. So we'd like to thank Kevin and Barb for hosting us today. And the ARFF working group. It's great to get out and talk to folks, and the last year it's been challenging to do that. So these webinars are a great way for us to communicate with the industry and show what we have to offer. So with that, I'll start getting into the presentation. If you do have any questions as we go through, you can put those in the chat, and then when we get to the end of the presentation, we can circle back and answer some of those questions for you. So two topics to talk through today. One is going over some of the details on the design of the Eco EFP system. And then, like I said, go over some of our installation experience as we've been doing retrofits in the field and actually shipping trucks with this on from the factory. So the Oshkosh Eco EFP system is an input-based foam test system that we've developed for the Striker. It is totally integrated into the vehicle itself, and it is one of the FAA-approved systems available out there through the funding sources. We have kits available and the opportunity to order it on new trucks. We have retrofit kits for all the different vehicle combinations, 4x4, 6x6, and 8x8, both in the Gen 1 vehicle that was introduced about 2001, the Gen 2 Striker that we went into production in about 2010 with, and then the Gen 3 Striker that we've just released here in January. That will be starting to roll into production this fall here. That will be available as an option on new vehicles coming out at that time frame. Like I said, the system is integrated into the vehicle. It's actually part of a functional system within the foam system on the truck. It's available for vehicles that have both the poppet foam system and the electronic foam proportioning system. It is compatible with both of those. And it uses two flow meters on the vehicle. One flow meter is actually measuring the solution flow that's coming out of the vehicle, and the other flow meter is measuring the foam flow through the foam circuit. And from there is doing the calculation to determine the foam percentage on the vehicle of that particular discharge. As you saw in the video, there's an operator interface at the structural panel on the truck. It is pretty self-sufficient. As you turn the system on, the system will actually prompt you and tell the end user what to do in each stage, as far as turning the foam system on, picking a discharge, telling the operator to turn a discharge on or off, and then saving the data at the end. So from an operational standpoint, just reading through the screen, it leads you step by step through the process to do the test itself without needing to refer back to a manual. The system has the ability to test all the discharges on the vehicle. So if you have a couple of hand lines and a roof turret and a bumper turret, all those are available to test through. On the turrets, we do offer the ability to do a low flow and a high flow setting for those also. So if you have a dual flow bumper and a dual flow roof on your truck, you can do 4 tests for those. And the way we designed the system is we really wanted to mimic the 412 output-based foam test. We tried to follow along with that logic as much as we could. As you watched the video, you could see that as you went into a foam test, you started the test, it gave you a 30-second runtime to let the system stabilize, and then there was a 10-second data collection period at the end. And really what that's trying to do is mimic that output pace test that you would do normally, where you would run the discharge for a while, let everything come into a steady state, and then at the very end, you would put the foam on the bang board to do get your test sample. So we really tried to follow along with that to mimic the 412 testing, just trying to be as common and as structured as that is. In that last 10-second test of the foam test, we're measuring data about every 10th of a second on that 10 seconds. We're taking that data and then we're averaging it, and that average data set from that last 10 seconds is the data sample that we're taking and using for that discharge. So, and as you saw in the video, there is a historical screen. All the data is stored on the truck. When you're done, you can go back and review this. On the current history screen, it will show you the latest foam test for each discharge. It'll give you the actual foam flow out of that discharge, whether it's a hand line or a turret. It'll give you the foam percentage, and then it gives you that date and timestamp to go and look at. There's the archive screen from there. So that will go back and you can look at every test that was performed on the vehicle and go back in time. If you're doing multiple tests, maybe trying to troubleshoot something, you can go back and look at all those and verify what improvements or changes you've made to the system. And then all that is stored in the system, and with that USB and download button, you can download this all into an Excel file and have that stored for your data records off of the vehicle. Some advantages of the Eco EFP system. A simple to use interface. It's right there on the vehicle. You click the button. The truck tells you what to do step by step. You can give hand signals to the operator to engage and disengage the discharges on the vehicle. It's a fast test process. As you saw in the video, it takes about 1 minute to do a discharge test. And with everything being based on the truck, there's no setup or tear down time. Literally, you can take the rig and pull it out of the fire station, walk up to it and start a test instantaneously. And a minute later, you have a test result for that particular discharge. So it's fast, easy to do. No extra tools needed. There's nothing that you need to do, hook up and set up with flow meters. Everything is on the truck, so there's no setup time or tools that you need to store. And the testing can be done without taking the vehicle out of service. So if you go and take the truck out and you start a foam test and the alarm goes off, as soon as you release the parking brake on the vehicle, the truck will actually kick out of the foam test system and revert the truck back into normal operations. So there's really no need to take a truck out, hook any systems up to it, and keep it out of the frontline service if you're doing a quick test. And then some more advantages. All the calculation is done within the system, where we don't need to, the end user does not need to do any math or calculations to figure out the foam percentage. It's done in the vehicle. There's no manual timing. As you saw, the system does the countdown for you and does that timing and records the flow rates and gives you that foam percentage and the flow or the solution flow rate, which has got some advantages in troubleshooting that I'll talk about a little bit later. And then all the data retention is done in the vehicle, so there's no manual data retention that needs to be done. One of the neat things that we found with this system is it gives you the ability to do a lot of troubleshooting on the vehicle, whether it's the foam percentage is not working, or even if you're questioning what your truck is doing from a discharge rate standpoint, because we will actually give you a discharge flow rate for that particular discharge. And if you're making any changes on the truck or maintenance is working on the truck, it gives them an instant gratification or instant check on if they were working on a nozzle and needed to adjust the springs on a nozzle. They could just go to a test back to back and verify that what they're doing is fixing the problem with a nozzle in particular. So it does have some advantages on troubleshooting along with the foam retention and reporting. As far as installations are, the Eco EFP system is available all on new trucks out of the factory. We do have retrofit kits for Generation 1 and Generation 2 trucks, both for the poppet and electronic foam systems. We've done kits with parts only, and the airports have done their own installations. And we've also done parts and labor where we'll have an Oshkosh factory representative come in and do the installation for the airports. If you do a parts order only, you will get a set of instructions that kind of leads you through step by step on doing the installation. And then if we do it ourselves, we'll show up at your airport and work with you to get the installation done. Really, if you want to get a quote, the best way is to talk to your Oshkosh sales manager. Definitely have a serial number for your vehicle. The serial number will kind of tell us over time. There's a couple of different variations of generations of trucks, and that will really get us honed into the right kit, just so we give you a good quote on what is needed for your particular truck. So that's kind of a wrap up of the features and benefits and how the system actually works. I'll roll into some installation experience. We've done a fair number of installations out in the field, and just kind of give you some tips and tricks and things that we've seen in the field and things to be aware of. So with that, I think probably the biggest thing is being ready and having a plan. Just being prepared for the installation. The truck will need to come out of service and be offline from frontline service to get the kit installed. Couple of things here to kind of help that process go as efficiently as possible is having the proper tools. There's a lot of big pipes and valves that get manipulated for these installations, so having a right set of tools is key. Having some kind of lift equipment. Some of the installations have very large valves and pipes that need to get installed, so a transmission jack or something like that is very beneficial to keep people from killing their backs on doing the installation. So having those would be great. And then having enough space in the area. We found that it's nice to do some sub-assemblies and build up sub-assemblies, then put that sub-assembly in the truck instead of just trying to put it in piece by piece. That's helped us out. So having some space to work around the truck, whether it's in the fire station or in the maintenance department, is definitely key and nice to have. From an installation standpoint, the Generation 1 trucks take a little bit longer than the Gen 2 trucks do, just based on the firefighting piping configuration. But, worst case on a Gen 1 truck, it's almost a week to do an installation. And then on the Gen 2, if you have an electronic foam proportioning system, it's actually just a couple hours to get the installation done. So depending on what vehicle you have, you can kind of plan around those times. And then the next item here, set a baseline. I think if anybody gets one thing out of this presentation, it's this, is to make sure that there's a baseline set before we do the installation of the Eco EFP system on your truck. Make sure the test or the truck is tested beforehand, is operational, and it's shooting the right foam percentage before we do the installation or you do the installation. If you don't know where you start with and you do the installation and the foam system isn't working right post-installation, if you didn't do that baseline, we really don't know if it was a system installed or if it was actually the truck having an operational issue before the installation. We've run into a lot of this, and what it does is it drags us down from a troubleshooting standpoint, and we actually work backwards in time and really got to go back through the basics of the truck to do the installation. And really what this does is it keeps the truck out of frontline service for longer than it needs to be. So really that's key to making sure that the installation goes quickly and we can get the truck back into service in a quick amount of time. A few other things to note, just talking about, numbers. NFPA 414 for a discharge requires the solution flow to be minus 0% to plus 10% for a flow rate. We at Oshkosh typically design and build to about a plus 5%. So if you have a 1250 roof turret, that's the nominal flow rate. In reality, you'll see a flow rate that's a little higher. And if it's that plus 5%, you'll see that 1313 GPM. So just as people have gotten into this and they've thought it's a 1250 roof turret, and they've actually seen higher flow rates, really that's because we're overshooting for that percentage just to make sure that we fall in the accuracy percentage for NFPA. And then same thing with the foam. If you're looking at a 3% truck, a turret is a 2.8 to 3.5% foam percentage. That is the nominal 3%. The 2.8 to 3.5 is the actual rate that is acceptable and approved through 412. So sometimes folks get a little too concerned of it needs to be 3.000% foam where that variation in there is acceptable. So just knowing those numbers as you're going through this really helps the process and just how we design our trucks and build our trucks and what you should actually see for actual data coming off the vehicle. Installations and having problems afterwards. We've seen just about everything from our installations in the field. A lot of common things that we have are component issues and system issues. We've kind of seen probably one of each of these, if not more. On the component side, probably the biggest one that we've seen is relief valves that are stuck, that are gummed up with foam over time, where you're actually adjusting the relief valve, but the spring's not operating, and that's affecting the adductor with the foam. Foam poppets stuck. We've seen those stuck closed. We've seen them stuck open. Nozzle issues, the springs and plates in the nozzles kind of get out of spec over time. And we've seen trucks that would have a 375 turret that was only flowing 250 GPM, but yet the foam poppet is opening properly. So then the foam percentage turns super rich. We've even seen some ball valves not operating where over time they've gotten gummed up or have gotten something in them where the ball valve won't open up either. System issues, I've seen just a wide variety of those. Relief valves not set right, air and electrical air connections as trucks have been worked on and serviced over the years. Swapping the air lines between poppets is one that we've seen where swapping a hand line and a turret poppet air tubing. So when the bumper turret opens up, it's only opening up the foam orifice for a hand line. So once again, going back to that, knowing that your truck is ready to go and test before we start doing this installation will really help us. And as we get into errors, we kind of go back to all of these things and we start that troubleshooting process from the very ground and working it forward. So another thing with the Eco EFP system is as you do a test, it'll show you that foam or solution flow rate. So if you have a nozzle issue and it's a 1250 roof turret and your EFP system or your Eco EFP system is saying that you have 1000 GPM, you're not flowing right. So is it a nozzle issue? Is it a ball valve issue? It'll help you troubleshoot those things just outside of giving your foam percentage. So. Installation experience with other systems. There's a couple other systems on the market. We've had some experience with those systems going on the Oshkosh Striker. Some of the things that are struggles we've had is just verifying that discharge rate. Just don't take the nominal flow rate, knowing that it's not exactly what that truck is flowing. The other one that we've seen is tank pump out errors. If you're just doing a drop down test to empty a tank, a 3,000 gallon water tank on a 6x6 really isn't 3,000 gallons. For NFPA 414, we need the nominal tank volume at 3,000 gallons needs to be done at a side slope, ascent, and a descent. So you need to pump out 3,000 gallons at those. So if the truck is on flat ground, it's probably 3,300 gallons or 3,400 gallons of pump out in the tank. So if you're assuming that you're doing a tank pump out, then that's 3,000 gallons. It's a little bit of an error there. All of the trucks that get delivered will have a tank sheet from the tank supplier that will show the flat pump out volume. So it would behoove folks to go back and look at that data and just verify that number before they just take the nominal number to do the tank pump out. The other one is only doing a test once. With manual timing and looking at flow meters, having the ability just to do one test and maybe somebody hits a stopwatch too quickly or misreads or miswrites down some bit of information that can lead to some kind of circles in troubleshooting. So doing the test maybe 2 or 3 times just to get an average on that would be beneficial to help some of the misinformation. With the Eco EFP system, we actually have that runtime and we're taking multiple samples of data. So we're kind of doing that automatically in our system because we know if the system reads and maybe you catch a low number or a high number, you could get a false reading. So taking that average over time will definitely be beneficial. And then in the end, if you do have an installation of another system outside of the Oshkosh Eco EFP and you have any questions, please contact us before you make any changes to your vehicle. We can help troubleshoot. There may be something that was changed on your vehicle over time and the turret may have been swapped out on the vehicle and we would probably have that in our service records. So before you go making too many changes, consulting us would definitely be beneficial to help us troubleshoot what you have. And with that, that's all I had for a presentation. Once again, I'd definitely like to thank the ARFF working group for hosting us today and Kevin and Barb for kind of running the show here. And Kevin, I don't know if there was any questions that came through during the conversation or not, but we'd be happy to answer any questions now.
Yeah, we got a few questions. The first one is from Wes Patterson. Retrofit kits don't come with automatic foam proportioner. Is that correct?
An auto. Try it.
So I'm guessing he's asking do you get new foam poppets if that foam proportioners, that's what I'm figuring out.
Okay. Yeah, if it's a poppet system, what you'll get is the two flow meters, the solution and the flow in the foam flow meter. You'll reuse the poppet box and the poppet valves, and you'll get some new piping to put those flow meters in the system. So the poppets there won't be new poppets supplied with the kit.
Second question is Martin Fox. He is from the UK. Understanding the system is approved by the FAA, can I ask to do other regulatory bodies around the world, ICAO, EASA, national authorities accept the Eco EFP test as an acceptable means of compliance foam testing instead of actual discharging foam onto the ground?
That's a great question. Have had that question a lot. And the FAA is really the only regulatory body in the world that has gone out. When the FAA went to approve systems, they actually brought systems in and worked with the OEMs to go through that testing. None of the other bodies, whether it's ICAO or ESA or even Transport Canada in Canada, have gone through. We've sold systems outside the United States, but I do not know of any of the other regulatory bodies that have gone through and done a validation test for that.
All right. Does the system use the same foam proportioners of the vehicle? And I think you answered that in your presentation.
Yeah, so whether it's a poppet system or our electronic system, the main proportioner parts are the same that are installed in the truck. We're adding the flow meters and the controller, and then we're using the foam flush circuit. So the controller is tricking the truck into using the foam flush circuit instead of the actual foam system to pull the water out of the water tank and put that through the foam system. But I'd say probably 90% of the foam piping and foam proportioning components are the same as a standard foam system.
That bleeds us into the next question. Is the water taken from the main tank or another reservoir? You just answered that one.
Yep, it's from the main tank just through the flush circuit. So, yep.
Any concern about cold climate?
Trying to think if we've had a whole lot of. I wouldn't expect to see any. Really, the viscosity of ARFF is about the same as water. So, and that really doesn't change a whole lot with temperature. So I wouldn't see that affecting the system.
All right. And how about drainage time? Does that have anything to play with it?
Yeah, so that's one of the key things that Keith Baggett and Mark Tunnicliffe at the FAA kind of, we discussed as we were testing these systems out. Really, from an operational vehicle standpoint, we're verifying that the foam percentage proportioning is properly done. So if it's a 100 GPM discharge, it's 97 GPM of water, 3 GPM of foam. It's doing that right mixing. You got that right discharge coming out of the truck. Really, the expansion and drain down times are a function of the foam interaction with the water and really not tied to the vehicle. So as Keith and Mark went through this and we talked through the logic of if you're doing the proper proportioning in the vehicle and it's coming out at that 3 or 6%, really after that, if you have good foam, it's going to have the right expansion and drain down time. So they've kind of taken that logic upon their approval of these systems, that knowing that if it's properly proportioned and you have good foam, that drain down and expansion are correct. But no, none of the output or input based systems test for that.
All right. We got one from Alejandre. He is one of our section. He was asking about, should the water's pump be calibrated to 250 PSI for proper foam dousing or calibrated at another pressure in generation 2?
To answer that question, Gen 1, I believe, is the relief valve should be set at 240 PSI, and Generation 2 should be set at 250 PSI. And that's going off my really bad memory. So I'll recommend everybody look at their operator's manual because that will be in the operator's manual. But I do believe that the two pressures between Gen 1 and Gen 2 are different. And definitely having those set properly will make the adductor work properly and meter the right foam. So if that relief is set to 200 PSI, you definitely will not be regulating the foam at the right percentage.
With that being said, will that be also in the FAA paperwork that you guys, that comes with every truck, the FAA certification paperwork, that release valve should be set to factory standard when doing this?
That is a correct statement, yes. Yep.
There you go. All right.
And usually when somebody says they're not getting the right foam percentage, the first thing that we tell them to go check is the relief valve and make sure it's set at the right setting.
I'm flipping through all the chat here, so that's why I'm just for testing hand lines on a new truck with the system factory installed. Do you need to set a manual proportioner, or is that done automatically with this system?
For the proportioner, it will be automatic. So whether it's a poppet or an EFP system, it will proportion the foam properly. There's nothing special that needs to be done for a hand line for setting the percentage of foam. If somebody is operating the truck in a structural mode and putting 3 or 4 hand lines on with a variable nozzle. The system really, when you go to that, you're kind of using the hand proportioner. So that would be the only time that you would want to set the hand proportioner is if you're in a structural mode, not in a ARFF pre-connect mode.
Okay.
I hope that makes enough sense.
Yep. Will the kits and new vehicles come with a poppet drain system to prevent unnecessary ARFF to be discharged?
So really the Eco EFP system is really bypassing the foam side of things. Our poppet box does have a drain to it. So if you go and shoot foam and do your normal, if you're in a fire operation and we're actually using real foam, there is a drain in the poppet circuit to open up. And as you go and flush the circuit, you should be able to flush all that foam out of the foam poppet box. When you go into the Eco EFP system and you're doing an input-based test system, we're not opening the foam system to the piping circuit at all. We're bypassing that and using the flush water from the water tank through the foam system. So during input-based test system, we're not introducing any foam to the circuit at all.
All right, that's the last question we had. And does anybody have anything else? If you do, just drop it in the chat box. And if not, we will thank you very much for today. And we thank Jason very much for being on here today.
All right. Kevin, thank you for your time today and letting us present. And we hope to see you this fall in St. Louis.
Yep, I'm going to hopefully be there.
Thanks, Jason.
And I have not seen any new questions come in.
All right.
And Ron said thank you as well.
All right.
Yep, lots of thank yous.
Yeah.
Okay.
So how many systems have you guys built, Jason? With this?
Retrofit kits we've done, I would say maybe about 40 in the field.
Okay.
As far as new trucks go, trying to remember the number, we're 150 systems.
I was going to say it's pretty easy to put it on when you get a new one.
Yeah, it's fairly easy to click the box. It comes pre-installed. From an overall vehicle price, it's not a large percentage to tick that option box. And with it being certified by the FAA, it really makes that annual foam test a lot easier and makes everybody's life a lot easier.
Well, I guess the worst part about it is, trucks are very competitive. And, you have one of brand A, one of brand B, and one of brand C. It's hard to get them all to match a certain system. So
yeah.
that's the pull the hair out. Let's go with that one.
Yeah, and if you look at any of the systems out there, if you're putting foam on the ground and you have somebody cleaning up and doing your foam recovery for you, the option price for one of these systems
pays for itself.
Pretty reasonable. 1 year annual foam test will pay for the option on the truck.
Yep. So. But doesn't look like any new questions. So we appreciate everybody's time today. Barb, do you have any final thoughts for us?
No, just that we will send the replica of today's presentation out probably by tomorrow afternoon at the latest. And for those that did not get to attend the live program, they'll still have an opportunity to ask questions to Jason. They'll go directly to Jason's email if you have any additional questions while you're reviewing it. And thank you again, Jason. We really appreciate it.
Yep. No, thank you for hosting us.
Take care.
Yep.
All right. Thanks, everybody.
Have a great day.
Bye-bye.
Yep. Bye.